Okay, so to go over that maximizing revenue problem, so it says Rachel and Ken are knitting scarves to sell at a craft show. They're planning to sell the scarves for $10 each, the same as last year when they sold 40 scarves. So $10 each, and they sold 40. Okay? So it says they found out that if they adjust the price, they might be able to make even more profit. So they've been told that for every 50-cent increase in the price, so if they increase by 50 cents, they will sell fewer scarves. So they'll lose 4 scarves. Okay? And then it says what selling price will maximize their revenue, and what will the revenue be? Okay, so to make this equation, I always suggest kind of thinking about it a little bit, okay? So if they started with 10, right? If they increase it to, so if they leave it at 10, then their profit is 10 times 40, 400, okay? If they increase it once, right? Then they're gonna lose 4 customers and they'll have a new revenue. If they increase it again, so 2 times 50 cents, they'll lose 2 times 4 customers. Okay? If they increase it again, they'll lose 3 times 4 customers. Okay? And so here, equations start emerging where the thing that's changing is either how many 50 cents we're adding on and how many 4s we're taking off, right? So I can say, okay, well, this depends on how many 50-cent increases we're making. So I'm going to say let X represent the number of 50-cent increases, right? And then I'm going to say f of x is the revenue, right? The money that they're making. Okay, so now I look at this and I say, well, my equation is just 10 plus 50 cents, 2 times 50 cents, 3 times 50 cents. So it's 50 cents times x. 50 cents times 1, 50 cents times 2, 50 cents times 3. And then times, I start with selling 40, and I lose 4 times 1, 4 times 2, 4 times 3. So it's 4 times the number of increases. And this is my function that I'm trying to maximize, right? Okay, so now if I want to maximize this function, the first thing I want to do is I want to try to simplify it a little bit, and then I'll change it to vertex form, right? And so to simplify this function, I'm going to expand it out. So 10 times 40, 400. 10 times negative 4, that's minus 40x. 0.50 times 40, that's plus 20x. And 0.50 times negative 4, so that's minus 2x squared, right? Now I'm going to collect like terms. So 400 minus 20x minus 2x squared. And then I'm going to rearrange it so that the squared term is first. So my final function is negative 2x squared minus 20x plus 400. All right? And now I have to change this to vertex form so I can see what the vertex is. All right? Well, we know that the process to vertex form is to first group these first two terms together. And then I'm going to factor out the A value, because I know that what I want my form to look like is something like this. Right? And so I'm going to factor out that A value. So that's -2. And then here I'm left with x squared. And then when I divide this out by -2, I get plus 10x. And then plus 400. Because that's going to be part of my k, right? So I'm going to leave that out there. Okay, so now I know that here I need to add and subtract something so that I have a perfect square. And so that something is always this number, so positive 10 divided by 2 squared, right? And so 10 divided by 2 is 5, 5 squared is 25. Okay? And then I add it and I subtract it because it doesn't make a difference. Okay, and then I know that this part here is going to factor into a perfect square. And so that means that I have f of x is -2, and then this bracket, and then this part I'm going to factor. So x squared plus 10x plus 25, two things that multiply to 25 add to 10 are 5 and 5. So I can call it x plus 5 squared. Right? And then I have my minus 25 still. Okay? And then the last thing, well here, I don't have this double bracket, right? So I have to get rid of this double bracket by multiplying this -2 back in. So this -2 gets multiplied to this bracket, and this -2 gets multiplied to the -25. Well, -2 times -25 is plus 50. And then the 400 wasn't in the bracket, so I'm just going to copy it down. And then that gives me my function, which is -2 x plus 5 squared plus 450. Okay? So, what does this tell me? Well, if we take a look at what that graph might look like, right? Remember that's going to look like a graph that's 5 units to the left and up 450. And it'll open down. Okay? So what that tells me is that x is -5 and f of x is 450. Right? So this is the revenue. That's the highest y value. That's the highest revenue that they're going to make. So that's our max revenue. But the original question was also, what should they charge, right? Well, remember we said that they're charging $10 plus 0.50x, because they're going to do 50-cent increases. But we found out that x was actually -5. So this is -250. So it's 750. So they actually need to reduce the price so that they can get to that maximum. So they should do 5 reductions, which means that they're going to get more customers, because every time they increase the price, they lose customers. So if they reduce the price, they'll get more customers, and they'll get as much as $450. Okay? That's it.